Assalamualaikum. We are from Group 8 and our team consists 3 members, which is me, Muhammad Shukri, Ainin Sofia, and Muhammad Faisal. So the assignment is about tone encoder and tone decoder. So for the methodology here, the methodology employed in this study encompasses the implementation of tone encoding and decoding system using MATLAB programming. The primary goal of this project is to explore the utilization of digital signal theory in constructing an efficient system that transforms a stream of digits 0, 1, 2, and 3 into a series of frequency tones and subsequently decodes it back into the original digit stream. The underlying principle of digital signal processing, specifically frequency analysis and waveform generation, are applied throughout the methodology. So the system comprises 2 main components, the tone encoder and the tone decoder. The tone encoder converts each digit in the input stream into a pair of distinct frequencies that represent the tone to be encoded. The encoded tone have a fixed duration of 0.5 seconds and a frequency sampling rate of 8 kHz. So as we look to the encoder flowchart here, so first we initialize the variable, and then it will iterate through the message system, and then we will get the digit, which is our group digit is 1320, and then it will retrieve frequency. Next is generate tone pair, and then plot graph. Next is play tone pair of sound, append filter tone pair to the tone stream, and then it will tone stream waveform, and the last thing is plot stream sound. So for the encoder, to encode each digit, a tone pair is generated using the input stream. The delta function is used as the input signal, and 2 filter systems are employed to generate the filter tone signals for each frequency in the pair. The resulting tone pair is plotted, and the sound is played for auditory feedback. The filter tone pair is then appended to the tone stream. So for the decoder flowchart here, at first we initialize the variable, and then we will iterate through the message system. Next is extract segment of the tone stream, and then it will perform frequency analysis on the segment using FFT. Next, it will define the predominant frequency in the segment, and then it will compare the detected frequency with the expected DTMF frequency. Next is decoded digit based on the compression result, and then it will add the decoded digit to the decoded message, and then it will display the decoded message, and for the last thing is plot the decoded message. So for the decoding process, the tone stream is analyzed in segments. Each segment is subject to frequency analysis using the fast Fourier transform. The frequency with the highest amplitude are identified, and the closest matching frequency from the predefined frequency pairings are used to determine the decoded digit. The decoded digits are then appended to the decoded message.
Next, I'm going to show you the result for this assignment. So, as you can see here, this is our code for encoder and decoder part. This is our original frequency, and this is our input. This is our input message, which is 1320. So, from this code, we are going to generate 4 types of figure, which is 2 for encoder and 2 for decoder. It's also going to generate sound from the input message that we have here. So let me run it for you, and you can clearly hear the sound that I just mentioned just now. So as you can hear, the first sound that you hear it's not actually the first. The 4 types of sound that you hear is this one. It's actually from the input message.
Okay, for the discussion of the results, this is the tone pair. We got the value of 1, 3, 2, and 0. So this is the tone pair of each of the value, which is 1, 3, 2, and 0. And for the figure 2, this is the combination of the tone pair over here. Combination of tone pair of 1, 3, 2, 0 in one waveform. And then for the figure 3, this is the frequency spectrum for decoding the number 1, 3, 2, and 0. And then when we decode back the message, we get the value back, which is a 1, 3, 2, and 0.